Mars has been a subject of human interest from the dawn of mankind, from cavemen drawing pictures in caves of the funny orbit of Mars, as well as the Mayans who studied the heavens directly. It's always fascinated us. But in the last 100 years, starting with, H.G. Wells and all kinds of stories, we've progressed to a point where we know that Mars actually has all the ingredients to support life, or at least it had them in the past. Could life exist below the surface, away from the radiation, away from the dryness and the temperature extremes of the surface, a number of meters below the surface? Is that a more conducive environment today for life on Mars?
Ever since man became a thinking animal, what he really pondered was he alone in the universe? And it took thousands of years before his technology allowed him to make an experiment to find out. And I was lucky enough to be that very first experiment. Well, we went to Mars. We waited patiently until we could produce our first test. We had our soil sample and we squirted in this drop of nutrient, just a fraction of a drop, on a thimbleful of soil. And immediately, radioactive gas started coming out. We were astonished. We waited, we watched the gas continue to come out for the entire 7 days of the experiment. Then it was time to run the control. Squirted in that fraction of a drop of nutrient and essentially nothing happened. Right then and there, we had satisfied the pre-mission agreed upon criteria for life. We could have said, we've detected life, hung our hats up, grabbed a bottle of champagne, and celebrated. But that was not to be. Finding life is such a sensational thing that even if you've previously agreed on the test, when it actually happens, you double think. So the answer that was officially accepted was that there's some strange chemical in the soil of Mars that imitates life. That was 38 years ago. People have been proposing various chemicals to reproduce our results. They never had.
It's certainly time to turn our attention to the search for life on Mars. Over the past few decades, the missions have focused on geology. It's time to turn our attention to biology. But what those missions have told us is that the place to search for evidence of life on Mars is below the surface. The deeper the better. We've only gone a few centimeters. We need to go meters down. We've also learned that the search for life on Mars is best done in many different locations spread out over the planet. The polar regions, Yellowknife Bay, where Curiosity drilled. These are all sites where it'd be interesting to go deeper underground. ExoLance can do that. Small payloads that can go to many different places and that can penetrate deep below the surface, do life sciences experiments. That's where I want to be, below the surface of Mars, many different locations.
So how does ExoLance work? Well, the idea of ExoLance is that we have a technology that's been developed for military devices called penetrators that can actually go meters below the surface. And we take advantage of the fact that as we're entering Mars, we're actually coming in with a lot of excess velocity. And these things will separate off of the main vehicle as it's entering Mars' atmosphere, take advantage of that excess kinetic energy, and bury itself 1 to 2 meters under the surface of Mars. At the same time as it hits, we're going to allow it to break in two, which sounds kind of funny if you think about it, but the reason for that is we want the top part to stay on the surface of Mars with the radio and the comm antenna so that it can relay the data back. Meanwhile, the penetrator and the payload go down below the surface of Mars, and that's what allows them to do the detection of life or other kinds of scientific investigations somewhere 1 to 2 meters down, where if there are living organisms on Mars today, scientists think they're more likely to be found.
In the first phase of this historic process, we will use your contributions to build and test the ExoLance delivery system here on Earth within the first 12 months. Once we prove the system is feasible for impact and surface penetration, our next phase will be to develop the science payload for detection of microbial life. In our advanced stage, we will manufacture fully integrated systems and make sure that ExoLance is mission ready for Mars. If, like us, you think it's time to turn the focus to Mars, then join us. Your contributions will help solve tough engineering challenges and advance Mars exploration. We're excited for you to be a part of this. With ExoLance, we can break new ground together.